Hey, Javid. This presentation is going to be covering energy and food webs. So look this over and then work on the questions, and we'll chit chat and discuss it later. Okay. So the first thing we need to know is what a heterotroph is. If you remember, plants from photosynthesis, plants are called autotrophs. Other organisms like us, like humans, are called heterotrophs. Okay, we get our food from consuming other things, other organisms. We eat plants or animals. All right. So just know that all energy comes from the sun. All right. So it always comes from the sun, and energy only goes in one direction. Energy is not recycled. Okay. So it comes from the sun to the plants, and then it moves through the food chain through the consumers. Okay. But energy is not recycled. This is sort of a good diagram showing you the energy coming out to the producers, which is the plants, and then it goes to the consumers, which is like insects, all the way up through great white sharks. And then when producers and consumers die, decomposers do their job and send the nutrients back into the soil so the plants can take it up. Okay. Again, we already covered photosynthesis last week. This is just a reminder of photosynthesis. All right, so this is consumers, okay, and this is the heterotrophs. These are organisms that cannot make their own food, so we have to eat stuff. So if you're a herbivore, that means you eat only plants. So herbivores eat only plants. Carnivores eat only animals, okay? So a carnivore only eats meat. Omnivore, which are what humans are, we're called omnivores. We eat plants and animals. There's also something called a detrivore or a scavenger. So if you're ever driving down the road and see like maybe a dead deer on the side of the road, and there's some black vultures eating it, those guys are called detrivores. They do not hunt, but they find things that are already dead to eat, to consume. And then lastly, there's decomposers, and these are like the mushrooms you might see. And there's also bacteria in soil. They break down dead organisms, usually plants, but also animals, and return the nutrients back to the soil so that the plants can use them. Okay, so decomposers are good for an ecosystem. All right, so we're going to be looking at food chains and food webs today. A food chain is just like a series of steps. That'd be like the plant, like grass, then a grasshopper, then a frog, then a snake. Okay, that's just one little line. A food web is a bunch of food chains overlapping and showing all the feeding relationships within an ecosystem. Okay, and each step up a food chain is called a trophic level. The first level is called the producer. That's like the plants. The second level is the primary consumer. That's like the first consumer. That's usually a herbivore. It's always a herbivore. It'd be like maybe a rabbit or a grasshopper or some kind of other insect. Just something that eats plants only. The second level is what they are. The third level is the secondary consumer. That's like the second thing to eat. That's what eats the rabbit or eats the grasshopper. And then the fourth level, that's like the big predator in an ecosystem. That might be like a great white shark, a human. It's also good ones are also like birds, like owls and hawks and falcons and eagles. Okay, those are great predators. And this is sort of a good example here. So you have producers. The producers here are the plants. The primary consumers would be like the grasshopper, or a mouse, or a rabbit. Secondary consumer would be like a mole or a snake. And then the tertiary, the big predator is an owl in this case. Owls are creepy, but they're great predators. All right. There's also something you need to know is like if something's really complex or difficult looking, like this purple side, this side here, this food chain or food web here is much more stable than this really simple looking one over here. Okay. And a way to look at it, say these snails right here and right here. If I took away these snails, all these things here still have something to eat, right? These guys here still can eat the minnows or the shrimp or the oysters. Over here, if I take away the snails, the shorebirds have nothing to eat. So the shorebirds are going to starve, and the hawks and the coyotes are going to move away. So the more complex or more difficult it looks, the more stable and healthy that ecosystem is. Here's another example, just showing you like a marsh, like an estuary. I like estuaries, so I always put these in here. But it's just showing you another food web. All right, we're going to move through this pretty quick right here. We're not going to cover that today. We're going to cover this today. And this is the 10% rule, okay? And what this says is that every time you move up a step in the food chain, the level that you're moving up to, it retains or only keeps 10% of the energy from the prior level. The other 90% is lost as heat or just lost as processes, okay? So if the plant's got 100 units of energy, the grasshoppers will only get 10 units of energy, okay? So each step up a food chain, you only get 10% of what the prior level had. This also explains the weight needed. So if I have 100 pounds of grass